1. Linear regression. Imagine you're trying to predict your future salary based on the number of years you've spent in school and your work experience. You collect data from a group of professionals, plot their years of education and experience against their salaries, and then draw the best fit straight line through these points. This line helps you estimate your salary for any given level of education and experience. Key concept. Linear regression finds a linear relationship between input variables, education, experience, and an output, salary. Example. Predicting house prices based on the number of bedrooms, square footage, and location. 2. Logistic regression. You're deciding whether to bring an umbrella based on weather conditions. You look at historical weather data, including temperature, wind, and cloud cover, and calculate the probability of rain. If the probability exceeds a certain threshold, e.g., 50%, you decide to carry an umbrella. Key concept. Logistic regression predicts a binary outcome, rain or no rain, by calculating probabilities based on input features. Example. Determining whether an email is spam, yes, no, based on its content. 3. Decision tree. Choosing a restaurant for dinner is a step-by-step process. First, you decide if you want something fancy or casual. Then, you choose between Italian and Chinese cuisine. Finally, you consider how far you're willing to travel. Each of these decisions forms a branch, and by answering these questions, you eventually arrive at the best restaurant choice. Key concept. Decision trees split data into smaller subsets based on conditions to make predictions or decisions. Example. Predicting whether a loan applicant will repay based on income, credit score, and job stability. 4. Random forest. You're trying to choose the best movie to watch. Instead of relying on one friend's suggestion, you ask a group of friends. Each friend gives their recommendation based on their own preferences, and you tally the votes to make a decision. The final choice is the movie that most of your friends agree upon. Key concept. Random forest builds multiple decision trees, each trained on a random subset of the data, and combines their predictions through majority voting, for classification, or averaging, for regression. Example. Predicting whether a customer will buy a product based on their age, browsing history, and purchase behavior. 5. K nearest neighbors, KNN. You're deciding what to wear to a party. You ask your closest friends, who share your fashion sense, what they're wearing, and based on their responses, you make your choice. If most of them are dressing formally, you follow suit. Key concept. KNN predicts or classifies an item by comparing it to the K most similar items in the dataset. Example. Recommending movies to a user by identifying users with similar viewing histories. 6. Support vector machine, SVM. Imagine you're hosting a party and need to separate two groups, introverts and extroverts. You draw a line on the floor to divide the two groups. To avoid confusion, you make the line as wide as possible so that each group has plenty of space on their side. Key concept. SVM finds the optimal boundary, hyperplane, that maximizes the margin between two classes. Example. Classifying emails as spam or not spam based on word frequency. 7. Neural networks. Recognizing a face in a crowd is a complex task. Your brain processes features like eyes, nose, mouth, and overall face shape through layers of neurons to determine if it matches someone you know. Neural networks work similarly by processing inputs through layers to identify patterns and relationships. Key concept. Neural networks use interconnected layers of neurons to process complex data and make predictions. Example. Recognizing objects in images, such as identifying cats in photos. 8. Gradient boosting, e.g., XGBoost. You're learning to cook a new recipe. After your first attempt, you realize it's too salty. The next time, you adjust the salt. After a few tries, your dish improves significantly. Gradient boosting works similarly by iteratively correcting mistakes from previous models to build a strong predictive model. Key concept. Gradient boosting combines weak learners, simple models, iteratively, with each model correcting the errors of the previous one. Example: predicting customer churn based on service usage and feedback. 9. Clustering, e.g., K-means you're organizing a road trip with friends. To make the trip enjoyable, you group your friends based on their preferences: adventure seekers, relaxation lovers, and history enthusiasts. This helps you plan activities for each group. Key concept: clustering organizes data points into groups based on similarity. Example: segmenting customers into groups for targeted marketing. 10. Principal component analysis, PCA. You're packing for a trip but have limited space in your suitcase. To fit everything, you prioritize the most important items: passport, clothes, toothbrush, and leave out non-essentials. PCA works similarly by reducing the dimensions of data while preserving its most critical components. Key concept: PCA reduces the complexity of data by identifying the most important features. Example: visualizing high-dimensional data, e.g., gene expression levels, in 2D or 3D. 11. Naive Bayes. You're guessing what kind of movie someone will enjoy. Based on their past preferences, genre, actor, director, you calculate the probability of them liking a specific movie. You recommend the one with the highest probability. Key concept: naive Bayes uses probabilities to make predictions based on prior knowledge. Example: classifying news articles into topics, e.g., politics, sports, entertainment. Thank you for watching. Please share and subscribe my channel.